Hello, welcome back to Tutoring with Abdul. We earlier this week we talked about logic gates. We also covered the AND gate. Uh, we talked about that. We draw a couple circuits, and we did talk about the truth table for the AND gate. In today's session, we'll be talking about the OR gate. The OR gate is sometimes it's called any or all gate. This logic gate is used in digital electronics for various reasons. One will be a fault light. That means like if you're working with machinery, for example, I'll explain this right here. So this is your 24-volt circuit here. This is your one condition, and that's your light, for example. That is your fault light, and that's your 0 volt. And let's say like this is oil pressure too high or oil level too high. We have another condition, for example, and this condition it says oil level too low. We have one more condition. It says machine let's make it air pressure low. So any of these conditions, whether if this is on, if this is on or this is latched, this will be on, this fault light will be on, or the oil level is too low, this will come, the fault light will come on, or the air pressure is low, this fault light will come on, or all of these, if they're on, they'll make this output to come true. So, and that's how we call this this parallel part of the circuit is ORed with each other. Any of these conditions will turn on this output. That is the definition of OR gate, which is any or all gate. That's how we call it. So that's mainly used for the alarm system in this the circuit that I drew. Now it's also used in a machine start condition. Okay, B is a machine start if it has two or more than two HMIs. That's human machine interface. Let's draw this scenario too. If we have the control voltage 24-volt DC, we have a push button here. Let's say push button 1, and there's a start. Let's make something. We have a normally closed contact. Let's say like this should be a stop, or I can just put a button sign there. Stop, push button, and there is your machine start. So that's your 0 volt, 1, 2, and there's your another HMI screen somewhere on the side. Well, let's see, call this as MCR, and this is latched here. Now that MCR, we bring it that contactor for the latch. So either if you hit this push button 1 or push button 2, if the stop button is not pressed, because this is for the safety, we use safety as in a series circuit with everything else. If this is closed, that means nobody pressed it. If it is unpressed, and then you push button 1, the machine will start, because it will complete the circuit from this 1 to 2, and that MCR contactor will be closed. They'll turn on, this will close this contactor and will latch it from this way. But if you hit push button 2, in the same case, it will latch it from, current will go from here to there, and it will latch it again this way. So that's how we ORed it in push button scenario for the machine start condition. And that's couple scenario that I talked about. But OR gate is a very useful gate that we use it in digital electronics. So it'll be good to know about it. And we have more reason to talk about the OR gate, but I had a fault reset before here in this session, but that wasn't true, so I had to take it off. It wasn't making a good sense. I just erased it. So this fault light, and I explained it in machine start if it has more than one HMI. So that will explain how you use the OR functions there. OR gate can be understood as a parallel circuit, as we just talked about it. Says yes. In a common word, we say like OR gate is any or all gate. We said that because if any input is on or all gate inputs are on, the output should be on. We did talk about an example. Now let's do it again. Let's draw a circuit with two switches used in parallel to show what an OR gate looks like. So we have a lamp right here. To turn this lamp on, we are connected to 12. This is let's say it's a LED lamp or any lamp. So we have 12 volt DC power voltage coming into this switch number 1. It's wired up to switch number 2 also. So the current is not going any point here because they're both open. But if you press switch 1, it will complete the circuit and the lamp will be on. Yeah, and if you release switch 1 and press switch 2, it will complete the circuit this way, and the lamp will be still on. If you press both of them, it doesn't matter, the lamp will be still on. It will turn on both direction. So when will the lamp light up? So yeah, when you push switch 1, press switch 1, the lamp will be on. If you press switch 2, the lamp will be on. If you press both of them, the lamp should be still on. The only condition that's not on when they're both open, the switches are open, lamp will be off. So everything has a symbol. For this OR gate, symbol is this. It's kind of a little bit curved and going back here, and this is your input section, and this is your output part. So A, B, and the C is your output. I call it C. Some books call it X, some Y, some book, any name, you just name it. A and B are inputs, and C is output. So that's the OR gate symbol that we use. Now Boolean expression for the OR gate is, we talked about the AND gate, and there was a dot in AND gate. AND gate has a Boolean expression as a dot, but the Boolean expression for the OR gate is the plus. The dot was the multiplication from the math, and the plus is just addition from the math, but we use a plus sign to represent OR gate. A plus B is equal to C. That means input A or input B, when they are high, it will make output C high or output C true, or both of them when they are high, or when they are both true, the output C will be true. High mean if it's true or it's binary 1 or it's on. So it means if A or B are high or they are both high, it will cause output C to go high, or the output C to be turned on, or output C to be binary true or 1. So that's how we simplify that. A plus B is equal to C. That means either this condition, either input 1 is high or input B is high, input A is high or input B is high, or both input A and B are high to turn on output C, or to make output C high or true. So how we make condition? We earlier said in last lecture that to make a possibilities of these two inputs, what we will do, the possibility of two input is 2 to the power 2, so it'll be 4 possibilities. For the truth table, possibilities, I hope I spell it right, so we have 4 possible conditions. And how we determine that? So we have input A and input B and output C. Let's draw it again here so we can, that's a little bit too aggressive curve. So this is our AND gate. For example, if I have a LED light here, okay, that's not LED actually, this is, and there's a resistor, and that's going to ground. So input A, input B, and this is your lamp, or it's LED. So when will this LED be on? This is ground, and I will call it like R1. When input 1 is 0, input A is low, or this is not turned on, or it's turned off, and input B is turned off, the output will be automatically turned off, so this LED light will be not on. But when your input A is 0 or it's off, or input B is on or it's 1, so this OR gate will generate that as a 1 right here, and or this output will be high, and this will make it current, the current and voltage will go through this LED and resistor and make this light light up. In the opposite direction, if the A is on and B is off, the output LED should be still on. So A is 1, A is high, B is low, output will be still high. If they're both high, if this is on and this is on, the output will be still on and the LED light will be on. So that was the truth table. We have in English we said A, input A, in English we say, excuse me guys, input A, OR input B. That is same as this one. This is a Boolean expression. That is the Boolean expression. Boolean expression. And this is our simple expression, logic representation, the symbol representation. In English we said like input A or input B, and that is your Boolean expression. So let's see, as I said in last lecture, that we are not depending, we are only not limited to 2 inputs. We might have more than 2. We might have 3 inputs OR gate, or more than, just say more than 2 input OR gate, we have it more than that. We'll talk about those IC circuits. We might have some of the chip that we use in our labs. We have we might have more than 2 OR gates there. So that's how. For this one, the truth table will have 2 to the 3, 2 to the power 3. We'll have 8 possible possibilities for the truth table. For ABC, for example, let's draw this table and we will call the day. This is output D, A, B, oops, that's too close to each other, A, B, and C. This since it's OR gate, let's say the first condition is that all the switches are off, the output will be off. Inputs, these A, B, C are inputs, D is output. But if C is on and B and A are low, output will be high. If C is low and B is high and A is low, the output will be still high because we have one high. Only one input high will make the output high in OR gate. Now if your C is low, B is low, and A is high, your output will be still high. Now if your C is high, B is low, and A is high, the output will be still high, or it's true. And if your C is low and B is high and A is high, your output will be still high. And finally, if you have C is a true logic and B is a true logic and A is a true logic, your output C will be true also. So let's say we set 2 to the 3, we got 8 possibilities for that truth table. So we have 1, 2, 3, 4, 5, 6, 7. There is one missing. We are missing 1. Okay, so yes, we are missing one right here. So this is 1, this is 2. I went directly to 4. The third and between here will be 1, 1, 0. Will be input A, B, C. If that is on, this will be still on. This is D, output D. So it will be in between right here. Is that condition? If your input C is on and input B is on, the output D still be on. So we have 8 possible solutions. 1, 2, 3, 4, 5, 6, 7, 8. So 8 possible, not solution, 8 possibilities of the truth table. And that's how we get it. We have more than 2 inputs or gates. We will discuss them when we get to the combination of the logic gates. We'll have to combine them. Then we will make a couple circuits and we will work on breadboard. Until then, guys, go and review the basic of digital electronics, please. It will help you. And also go and check out those electrical studies. Since we did discuss about the series and parallel circuits, and also combination and the base of electricity. It will help you a lot in digital electronics. That will get you guys get going for the logic gates. Please don't forget to hit that subscribe button. I will see you next time with the next lecture. Until then, take care, guys.